Hello, this is a video on tangents and secants, part one. We're going to focus on what a tangent and a secant is and then how their arcs relate to them and angles that are created by tangents and secants and chords are related to the arcs. The second part of this video is going to focus on segment length and chord length that goes along with tangents and secants. So two parts. Try not to make it too long for you, but two parts here. This is part one, going to focus on tangents, secants, and arcs and angles. Here we go. So I've got two pictures for you here. Feel free to pause your screen and draw these pictures out. The pictures are going to be your definition. A tangent is a line that touches a circle exactly one time. Exactly one time. So that one point that it has in common with that circle is called the point of tangency. Seems pretty logical. So a tangent line is a line that touches a circle exactly one time. Now that's different from a secant. A secant is a line that touches a circle twice. So it has the ability to go through the circle. You can see that there are 2 points on the circle there. It goes in and comes back out. It touches a circle twice. A secant touches a circle twice. All right, so we're going to talk about how tangents and secants relate to the circle and their arcs and some angles that can get created. All right, here's our first example as well as our first theorem. All right, one of the things that you notice right away is that there is an angle created by a secant and a tangent. They intersect on the circle right there at the point C. So the angle that I'm focused on right now is right here. This angle that is created by the tangent and a secant. All right, now what our theorem tells us is that the measure of that angle that we just pointed out with the blue is half of the arc that is intercepted by that angle. So when I say the arc that is intercepted, we're talking about this arc right here. That arc right there is the arc we're talking about because that's the piece of the circle that's trapped inside the angle that's created by these two lines. All right, so what we're saying is the measure of that angle is half of that arc. So right away, I want to find the measure of that angle ACT if the measure of arc CBA, which they're telling us is this major arc CBA, if that's 276 degrees, that whole arc, we want to figure out what the rest of it is because this arc in green up here is going to be what we're going to then divide by 2 to get our angle measure. So what I'm going to start out with is the total arcs of 360 degrees, and I'm going to subtract the 276 that we know is our major arc, but subsequently is not the arc that I need to cut in half. So I'm going to find the difference between these. So really quickly, I'm going to do my subtraction and figure out that this is going to give me 84 degrees. So the measure of this arc here is going to be 84 degrees. There. So the measure of that angle is half of that arc. All right, so 84 divided by 2 is going to be the measure of angle ACT, which is 42 degrees. So that's the relationship here when a secant and a tangent intersect on a circle. All right, another scenario, our next theorem, you see you've got two secants intersecting inside the circle. Two secants intersecting inside the circle. Now, notice that they're not necessarily intersecting at the center, so they're not making central angles. If they did, that would be a little bit easier relationship because arcs and central angles are the same, but we don't have central angles here. However, what this theorem is pointing out is this angle where angle 1 is, right here. That angle is going to be the average, so add them up, divide by 2, is going to be the average of the two arcs on either side of it. Now, you say on either side of it, it could be left and right, it could be up and down. All right, so Notice that the angle directly below that's highlighted, that would be the angle that we would say intercepts that. I'm sorry, that would be the arc that is intercepted by this angle. You can see that it's trapped inside that angle 1. Okay, so that, and then the mirror or the opposite arc of it, those are the two angles that we're talking about. Notice that 1 and 3 are vertical angles. So the two arcs, they're not necessarily called vertical arcs, but you could think about them as vertical arcs. So those two are the ones we're going to add up and divide by 2 or find their average. Okay, so the measure of angle 3 is what I'm looking for. So if I know angle 1, I'm going to automatically know angle 3 because the vertical angles are congruent. All right, arc SR, which is the arc to the left that I'm actually not interested in, they tell me that that's 108 degrees. So this is 108. I'm going to label my picture with that. And they tell me that arc TU, which is the other arc that I'm not interested in, is 72 degrees. And I know what you're saying. You're like, why would you give me that information if I'm trying to figure out one? Well, let's see if we can use a little bit of geometry to figure that out. Well, remember the relationship is that either angle 4 or angle 2 is going to be the average of those two intercepted or quote unquote vertical arcs. So we're going to add those up, 108 plus 72, and divide by 2. We're taking the average of those because that's going to tell me what either angle 4 or angle 2 is. So this is 180 divided by 2, or 90 degrees. So like angle 4 right now is 90 degrees. Okay, well, what's the relationship between angle 4 and angle 1? They form a linear pair, so they add up to 180 degrees. So 180 minus 90 is going to be 90 degrees, and we just figured out the measure of angle 1 a little bit of an indirect way, but still using this idea of the average of the two intercepted arcs. So I just figured out that the measure of angle 1 was 90. Well, if the measure of angle 1 is 90, the measure of angle 3 would also be 90 because of vertical angles. So we just figured out the measure of angle 3 is 90 degrees. All right, another theorem that we have here is we have two secants intersecting outside of the circle. So you can see this angle CAT is 42 degrees and its vertex is outside of the circle. So when this scenario occurs, you're actually not going to find the average of the two arcs that are trapped inside that angle. You're actually going to find their difference and cut that in half. Okay, so again, the two arcs that I'm talking about are here and here. Those are the ones that are in the interior of that angle CAT. So when you have two secants intersect outside of the circle, the two arcs that are trapped inside, we'll do big minus small divided by 2. That's how we're going to do that. All right, so what's the information that we have right now? We know that 42 is supposed to be half of the difference between the two arcs that are inside. All right, another way of thinking about that is 42 is the difference divided by 2. Whichever way, I mean, those two things mean the exact same thing, so it's whichever one is more comfortable. Some people prefer fractions. Some people don't like fractions. I'm not a fraction person, but that's okay. All right, so what I'm going to do is I'm going to work my way. I'm going to try to get x by itself. So how would I do that? Well, I would multiply both sides by 2. Try to get rid of that fraction. And if I multiply the right side by 2, I have to multiply the left side by 2. So 84 is equal to, those cancel, and I've got x minus 27. Add 27 to both sides, and I get 111 equals x. So the measure of that arc is 111, and that's what I would do to solve for x there. So again, two secants intersect outside of the circle. That angle measure is half of the difference between the two arcs that are trapped in the interior of that angle. All right. Got a couple more scenarios for you, and I'm, for time purposes, I'm just going to point them out to you because they actually end up with the same relationship that we just solved. So this is a secant intersects a tangent outside of the circle. And this is a tangent intersects a tangent outside of the circle. And the relationships ends up being the exact same thing. It's the difference between the two arcs that are in the interior of the angle divided by 2, or half of their difference. So just like what we did up here, where the two secants intersected outside and we did big arc minus small arc divided by 2, you're going to do the exact same thing here. X would be half of the difference between the big arc and the small arc. So X would be half of 100 or 50 degrees. So that's how we would do that problem. Same thing would happen on this one. 84 is half of the big arc minus the small arc. Well, they tell me that arc IXI or IXJ here, that's this big one. This one right here, IXJ. They told me that that was 220 degrees, so that's definitely the big arc. So here we go, 220 minus M, and then I would just solve for M. So multiply both sides by 2. 168 is equal to 220 minus M. Subtract 220 from both sides, and you get 52 is equal to, negative 52 is equal to negative M. So 52 is equal to M. And that's how we would do that. So all three of those scenarios, whether it's two tangents, two secants, or a secant and a tangent, if they intersect outside of the circle, you're going to do big arc minus the small arc divided by 2. That's what the angle is equal to. All right, I hope that was helpful. I hope these scenarios were clear to you. Remember that a tangent is a line that touches a circle exactly once, and a secant is a line that touches a circle twice. Thanks for listening. Good luck.